All right, ladies and gentlemen, today what we're going to be doing is we're going to be looking at how to do distributive property, but with expressions with variables. So yesterday, some of you might have been thinking, especially for some of the easier examples, why do I need to even know how to do distributive property? It's easier just to add these numbers and then multiply, and I can get to my answer. Well, the reason why we need to talk about it is because when we have these sorts of expressions, we can't combine them together. When I look at this one, I can't start doing 2x plus 4. I don't know what that equals, okay? So here I have to use distributive property in order to sort of start to simplify what I'm looking at. So what I'm going to do is I'm going to draw my double rainbow just like we did yesterday, okay? So 3 times 2x and 3 times 4, and I'll write that down here. 3 times 2x plus 3 times 4. And then I'll go ahead and I'll simplify from there. So in this instance, whenever you multiply by something that has a variable, you just multiply the number parts together. So 3 times 2, that's going to be 6x. And then 3 times 4, I know, is 12. Once I have something that looks like this, I am done. I actually cannot combine these together anymore. Okay, the x and the non-x part cannot be combined together. So we're done at 6x plus 12. That's our distributive property involving variables. Basically, if you just notice, the exact same thing we did yesterday. The only thing that's new is that now we have an x floating around, or an a or b or whatever variable we want to use. Let's take a look at number 2. Here I have 5 times negative 2x plus 6. So I'll go ahead and I'll do my distributive property, draw my double rainbows. I'm going to have 5 times negative 2x plus 5 times 6. And now that I have that, I'll go ahead and multiply these. 5 times negative 2 is negative 10x. So notice I just multiply those and then write the x afterwards. And then 5 times 6 is 30. Distributive property with variables. Same thing I did yesterday, just adding in that small extra step because I have that x there, okay? Down here, do the same thing, draw my double rainbows. Negative 4 times x, and then plus negative 4 times negative 1. Now, there's two ways to think about this. When you go to do your negative 4 times x, it's just going to be negative 4x. That's your answer. Some people, what they like to do is they like to think about the fact that because I don't see a number with this x, there's actually a 1 hiding there. And so it's like I'm doing negative 4 times 1 to get this negative 4 here. Either way you want to think about it, that's up to you, and it's fine with me. Over here, negative 4 times negative 1, I'm going to get plus 4, and there's our final answer. Last but not least, I have this kind of weird one over here, and it kind of correlates with this one over here because I just have a negative out front. And what the heck does that mean? What is that negative? It actually means that I secretly have a negative 1 hiding out front. So I actually can rewrite this as negative 1 times the 8x plus 5. And so because of that, I can go ahead and distribute this negative 1 to each part. And I'm going to get negative 1 times 8x plus negative 1 times 5. Negative 1 times 8x is going to be negative 8x. And then negative 1 times 5 will be minus 5. And there is my simplified expression using distributive property. One other kind of problem that they sometimes like to throw at you when you're doing this are these problems involving rectangles. Okay, they'll show you a rectangle and they'll say, hey, find the area of this rectangle. They'll say, hey, we need you to find the area. What's the area of the rectangle? Now, if you think back to geometry last year, you'll sit there and go, okay, area of a rectangle. I add up all the sides, right? That's the perimeter. For the area, what we want to do is we want to multiply the two sides together. So in this case, I'm going to be multiplying 3 and multiplying it by 5x minus 1. Now, if I just stop right there and look at this, if I ignored the rectangle portion and just looked at this, it kind of looks like distributive property, doesn't it? That's because that's all it is, okay? When we multiply these sides, we end up with a distributive property problem, and so we'll go ahead and solve that by drawing our double rainbows. And then we're going to have 3 times 5x, which in this case will be 15x. And then 3 times -1, which will be -3. And there will be our simplified answer. Okay, so all we do, set it up, do distributive property, same sort of thing. Down here, we'll do the same thing. We're going to have 2 times 4x plus 5. Again, when I find the area, I multiply the lengths times the width, or I multiply the two sides together. And I'm going to be set up with a distributive property problem. And I'll go ahead and I'll distribute. So I'll have 2 times 4x, which will be 8x. And then 2 times 5, which will be 10. A lot of times in math, as soon as we see variables, we have a tendency to start freaking out. Oh, they put letters in my numbers. I don't want that to mix. It's messing me up. You don't need to freak out when you see that. When you see these letters and these numbers together, these variables, they act exactly like when we just have numbers, okay? It's the same process, same thought, same properties apply. Distributive property, the exact same thing. The only thing that's different is now that we have to multiply with the x. So when I do 2 times 4x, it's 8x. I have to remember to write the x, and then I'm good to go. All right. Thank you for watching. Please go ahead and try the rest of the practice problem.